All right, so optimization day 2. So what we're going to do in these notes, it's really just practice. It's 4 practice problems, just like 4 problems that we did in day 1. Okay. Directions. Use algebra to complete the following problems. So we're saying don't use the graphing function on your graphing calculator. It says the John Deere Company has found that the revenue from sales of heavy-duty tractors is a function of the unit price P that it charges. If the revenue R is R equals negative 1/2 P squared plus 1900 P, what unit price P should be charged to maximize the revenue? And then what is the maximum revenue? So I need 2 things here. So we will start with the first one. What's the unit price P should be charged to maximize the revenue? Okay, so once again, when you're given an equation, it's the easiest type of problems, and we were given an equation, so we don't even have to come up with that step of coming up with the equation. All right, we know this is a downward-facing parabola, and no, you do not, it's not required that you draw a picture, but my brain works better when I think before I do. Okay, my input's P, my output's R. So this point right here is over P, and then the max revenue. Okay, so we're starting with what price P should be charged to maximize revenue. So I need to find that P value right there. So it's the X value of my vertex. So I'm going to do X equals the opposite of B, so negative 1900 over 2 times A, which is negative 1/2. 2 times negative 1/2 is negative 1, and then negative 1900 divided by negative 1 is 1900. So X is 1900. Therefore, P, the price, is $1,900. And I will highlight that in purple because that was the answer for that one. All right, the next question is, what is the maximum revenue? So now I want to find that R value. So I'm going to do R equals negative 1/2 times 1900 squared plus 1900 times P, which is 1900. I'm going to go ahead and use a calculator for this because no thank you mental math here. All right, ooh, clear. Okay, so I'm going to do negative, I'm going to do 0.5 instead of 1/2 because it's the same thing. 1900, close the parentheses, square it, plus 1900, parentheses, 1900. Close it, enter. So I got that as an answer. 3 zeros and then 8051, so $1,805,000. Not too shabby. I'll take it. And there's your revenue. Okay? So once again, when the equation's there for you, the easiest types of problems. Okay, next one. Farmer Ben has recently discovered that unruly young teenagers have been sneaking into his watermelon patch and stealing some of his precious watermelons. He wants to fence a rectangular watermelon patch, which is located on the corner of his farm, deep in beer country, in hopes of putting an end to the immense problem. He can afford 200 meters of fencing, and he wants to fence in as much area as possible. He will use his barn as one side of the fenced-in area, so he'll only need to make a fence on 3 sides. What is the dimensions that will give the maximum area? And then what is the maximum area? So once again, we're going to do this first, and then we'll worry about the maximum area. Okay, so sketch, because I want to make sure that I think about this right. So this time we have his barn, and he's going to make a watermelon patch, and he's going to make that using 3 pieces of fence. So 1, 2, 3. I don't know this length, so I'll call it X. I know this is the same, but I still don't know what it is. And then he has 200 meters of fencing. So I'm going to say that this could be up to 200, but I have to subtract those 2 pieces, those 2 X's. Do I have to divide it by 2? No, because there's only one part right here. Right? Okay, let's write our equation for area. Area equals length, which is x, times width, which is 200 minus 2x. Distribute. Area equals 200x minus 2x squared. So my area formula in standard form is negative 2x squared plus 200x. All right, so now I'm ready to find the dimensions. I need x to find the length, and I need x to find the width. So let's find x. This is a downward facing parabola, and I need to find that vertex. So I'm going to use x equals the opposite of b over 2 times a. So once again, I'm dividing by -4. It's negative, so that means the final answer is positive. Half of 200 is 100. Half of 100 is 50. So now I'm ready to find the dimensions. I know that the length is 50, so I'm going to say 50, and that is in meters. And I'm going to say by, and then I need to find out what 200 minus 2 times 50 is. So that's 200 minus 100, which is 100 meters. So there's the dimensions, 100 meters by 50 meters. And now I can answer, what's the maximum area? So easiest way is it's length times width, where I know it's 50 and I know it's 100. Area equals 50 times 100. Area equals 5 and 3 zeros. So 5,000 meters squared, because it's meters by meters. Once again, you can plug in the x value you got, which is 50, into this equation, and you'll still get the same answer. All right, next one. A gardener with 10,000 meters of fencing wants to enclose a rectangular field and then divide it into 3 plots with 2 fences parallel to one of the sides. What is the largest area that can be enclosed? Okay, so let's look at this. Rectangular fencing, it's not up against a barn or a wall or whatever, so I need all 4 of those. And then he wants to add 2 more fences parallel to one of the sides. You can do vertical or horizontal lines. Okay. And I once again only know the total length of all those pieces added together. So I don't know what this is, so I'm going to call it x, and I'll say this is x, and this is x, and this is x. Also, you can see that I divided into 3 plots. That's 1, 2, 3 plots. And now I have these 2 pieces to take care of. Okay, so I know that there's 10,000 total. I've already used 4 parts of it. And now I have to break that into 2 parts. So I'm going to divide this by 2. So I get 5,000 minus 2x. That means this is 5,000 minus 2x also. I like labeling both just to make sure it makes sense, all right? Okay, area. X times 5,000 minus 2x. So area is 5,000x. Oops, I forgot a 0. 5,000x minus 2x squared. Standard form, area is negative 2x squared plus 5,000x. Okay, so let's see what this one's asking me for. It is asking me what is the largest area that can be enclosed. So I need to know what A is. In order to find out what A is, I need to know what X is. This is another downward facing parabola. Max A value is going to come from the vertex of that parabola. So I first need to find the X value of the vertex of the parabola. X equals the opposite of 5,000 over 2 times negative 2. All right, so divided by -4, once again, is going to be positive. Half of 5,000 is 2,500. Half of that's 1,250. So I have X is 1,250. And this is units, meters. All right, so now I need to find the largest area, which is A. Okay, so I could either just say this is 1,250 and then plug in 1,250 here and multiply those two, or I can just plug in 1,250 here, which I'm going to do this time. So I'm going to do negative 2 times 1250 squared plus 5,000 times 1250. Let's run it into my diagram, but it's okay. Negative 2 parentheses, 1250, close it, square it, plus 5,000, parentheses, 1250, enter. So that is 3,125,000 units. Meters times meters is meters squared. All right, the very last one. At Soldier Field, a section on the 50-yard line has seating for 2,000 people during the Bears game. So even before I start reading here, the first thing that already bothers me about this problem is they put a number that's like useless. So I'm just going to be that person that crosses off 50 and is like, on the yard line, don't care, because 50 has nothing to do with the math problem. It has seating for 2,000 people during the Bears game. The tickets in this section cost $80 each. The Bears management has found that for every price increase of $5 leads to a loss of 100 fans in this section. What should the Bears charge for seats in this section to maximize the profit? What is the maximum profit? So I just realized that this year that there is no one at Bears games. So we should probably have come up with a different example here, but in the future, there will be Bears games. So let's continue on with it. All right. So first off, I need to say that my revenue, because that's what we're trying to see here, is how much should the Bears charge for seats, right? And it's going to be whatever the price they charge is by the number of tickets they sell. So tickets sold, or I'm just going to put sales once again. And then I need to write an equation for the price, and I need to write an equation for the sale so I can substitute in those expressions and get my equation. All right. So I got to see what's changing again because I kind of read that fast. Every price increase of $5 maximizes their profit or leads to a loss. Okay. So I just don't know how many times they're going to increase it by $5. So X is going to be the number of $5 increases. So I'm doing that to tell my brain that when I write my two equations here. All right, price. So they're $80 each, but they're considering doing $5 increases. Just, I don't know how many. So 5X. So they're going to, if there might be 3 $5 increases or 10 $5 increases, it's just that being multiplied by that. All right, the amount sold. So it seems like they sell 2,000 tickets, but they lose 100 fans per $5 increase that they do. So now once again, I'm going to take this, I'm going to substitute it in for price, substitute it in for sales, and get my quadratic. Okay? All right, so my quadratic is going to be R equals 80 plus 5X times 2,000 minus 100X. So I know for a fact on your test has it broken down into sections A, B, and C, where A says write an equation. So, and put it in standard form. So I'm going to continue to do that. All right, distributive property. So 8 times 2 is 16, and then 4 zeros. 1, 2, 3, 4. All right, so I did that. Now I have to do this. So it's minus 8 with 3 zeros. X. Multiply these two, that's 10 with 1, 2, 3 zeros. X. And then these two multiplied is negative 5 with 2 zeros, X squared. So I feel like it's easier to do that because you can totally mess up typing it in your calculator. Like to do it mentally, just count the number of zeros. Okay, combine like terms. So I have negative, and put it in standard form. Negative 500x squared, like term. So that's plus 2,000x, and then plus 16 with 4 zeros. 1, 2, 3, 4. Okay. All right. So there's my equation. Now let's see what it's asking me for because I was so goal-oriented on getting my equation here. What should the bears charge for the seats in the section to maximize their profit? So I know what they should charge. Okay. And then what's the maximum profit? So to find P, I need X. We know how to find X. X is equal to the opposite of B over 2 times A. So X equals the opposite of B, so negative 2,000 over 2 times A, which is negative 500. 2 times negative 500 is negative 1,000. Negative 2,000 divided by negative 1,000 is 2, right? Okay. Once again, you can use a calculator, but I'm not seeing that I need it that much with that. All right, so what is 2? 2 is the number of $5 increases, right? Because X is the number of $5 increases. So I'm going to do 2 of them. All right, now I can figure out the prices. So I'm going to say the price is 80 plus 5 times 2. So the price is going to be $90. So please make sure when you're doing these, you think, because you couldn't even imagine how many answers of 2 I get, like just the number 2, $2. And it's like, no, that's not what X, that's what X is. We want P. Okay, now I'm going to answer the final question, which is what's the maximum profit? So maximum profit, once again, 2 ways of getting this. I can plug into here also and then take that number times 90, okay? Or I can plug P or X into the revenue equation, which I'm going to do. So I have negative 500. Just make sure you don't plug in 90. Make sure you plug in X because it's times X squared. Plus 2,000 times 2 plus 16 with 4 zeros. All right, let's type that. Negative 500 parentheses 2 close the parentheses squared plus 2,000 parentheses 2 close it plus 16 1 2 3 4 zeros, enter. So that's what I got as an answer, which is $162,000. Okay. And we've answered both questions. All right, that's it for today's practice. You can go ahead and get started on